Welcome back to Math Concepts. In this video, we are going to continue our work in set theory. And remember, this is about giving us an example of a mathematical structure that is different from the number system. And when we're working in set theory, our objects are sets. And we're going to talk about the first operation that we will learn to do on these sets. And that operation is taking the complement of a set. So let's switch over to the document camera and look at some examples of finding complements of sets.
So if you are following along with the electronic version of the textbook on WebAssign, the material we are discussing is in section 2.2. And the key ideas for this section are being able to find the complement of a set. Okay, so after we're done with this video, if I give you a set, you should be able to find the complement of that set. So this is the one that we'll do right now, and these two outcomes will be in the next video. We'll talk about how to determine whether one set is a subset of another and how to count subsets of a given set. Okay, so in this video we're going to focus on complements. So let's get some definitions down here. The universal set is everything under discussion at the moment, and this is going to vary from problem to problem. Okay, so in one problem the universal set might be whole numbers from 0 through 9. In another problem, the universal set might be the set of all integers. In another problem, the universal set might be the set of all students at the college. So you'll have to be given the universal set in the problem to understand what's going on. Now, the complement of a set, this is the first operation that we're going to do with sets. Now, by operation with a set, I mean I give you a set and a rule, an operation to do on that set, and you come up with a new set. Okay, so the complement of a set is a new set, and it's everything in the universal set that isn't in our set. So complement is like the opposite of a set. Also note the spelling, this is spelled with an E, not an I. So let's look at some quick examples to understand how this operation of taking the complement of a set works. Okay, so for these examples, I'm going to take my universal set to be this one right here. Okay, we almost always designate the universal set by the letter U. And in this problem, the universal set is the set of whole numbers that are less than 10. And I want to find the complement of each set that we're given right here. All right, so the set that we're given in this first example is designated by the letter A, and they tell us that A equals 1, 3, 5, 7, and 9. So A complement, okay, now we have a shorthand notation for A complement. We just put that little prime by the letter. Okay, so that's the set A, this is A complement. All right, well, we want everything in the universal set that isn't in the set A. Now we notice A contains the odds, so A complement would contain the evens, 0, 2, 4, 6, and 8. Okay, so that's A, and that's A complement. I would also note that if you take a set together with its complement, you get the universal set. Okay, let's look at this next example here. This is given to us in set builder notation. Hopefully you remember this from the last section. Okay, so this is the set of all x such that x is a whole number and x is less than 5. All right, now for the purposes of this problem, I'm actually going to rewrite my set B using the roster method. And of course you remember that the roster method is when we list out the elements of our set. Okay, so my set B is set of all whole numbers less than 5. 0, 1, 2, 3, and 4. Okay, so that's my set B. Now, I am not done with this problem yet. Notice the instructions say, find the complement of each set. Okay, well, if this is my set B, B complement would be everything in the universal set that is 5 or greater. So it would be 5, 6, 7, 8, and 9. All right. Let me throw one or two more examples here. Let me take this set right here, the set C. And let's just say C is the set that contains only one element, 0. C complement would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, once again, we're following the rule that we're taking everything in the universal set that isn't in our original set. So we start with our given set, and we find the complement by taking everything else. And one thing I would note is that the smaller our set is to begin with, the bigger the complement is going to be, and vice versa. The bigger your starting set is, the smaller the complement will be. Let's go over here. Let's do two more examples. Let's kind of take that to the extreme. Let's take the universal set itself. Okay, now that was written on the other page, but I'm sure you remember what it was. It was whole numbers 0 through 9. I'll just do a little shorthand there like that. 0, 1, 2, we keep on going until we hit 9. Okay, if I were to take the complement of this universal set, well, think about it. Work it through logically. The complement of any set is everything in the universal set that isn't in our given set. But here we got the universal set, so there isn't anything in our universal set that isn't in our universal set. So that is the empty set. Complement of the universal set is the empty set. And that little relationship also goes the other way. If I want the complement of the empty set, that would be everything else. That would be everything. Okay, the complement of the empty set is the universal set. So once again, the takeaway from this video is the operation of finding the complement of a set. So make sure you go through the assignment on WebAssign and work through the exercises about finding complements. It's a very easy operation to do, just got to get some practice with it. Okay, our next video, which let's put a link to that right down here. Our next video will be about the idea of subsets.